All right, folks, let's do some test corrections. First of all, I'm very grateful for you this past semester. Nice work. Um, Thanks for being here. Thanks for showing up, being respectful, and being kind and working hard. So, how do you do these problems? And I'm going to give you a 10% raise back if you do the corrections and turn them back in. So, I'm hoping everybody does the corrections today, not just the people that maybe, you know, didn't do as well as they had hoped on this thing. Maybe you're down at 60 or 70%. You're going to have to do a few more corrections than the people that are at like 90%. So skip ahead in the video until you get to the part that you're looking for. This first one, it says BF right here. BF, this segment right here is 6 long. That's the radius, right? So every radius is going to be 6. I don't care if it's drawn here or drawn here or drawn right there. They're all 6 long, right? So FD is 6 long. The length of the diameter of M is 76. That means the radius is 38. Boy, I hope I don't make any arithmetic mistakes this morning. Yeah, 38 times 2 is 76, right? And then the diameter of J is 32. Okay. So, if I drew the radius from here to here, right, that length is 38. And then if I drew from here, let's change colors. If I drew from here to here, that length right there is 32. Okay. Now let's see. It tells me JK is 12 long. So that means that this piece right here is 12 long. Well, wouldn't it take me 20 right here? Wouldn't it take me 20 to get the rest of the way of the 32? Right? So if there's 20 right in here and the whole radius is 38, well, this part over here is 18. So as you kind of walk your way through that, that's called deductive reasoning. That's what we're trying to get better at is, the ability to look at given information and just make conclusions based off that given information. The next one, 5 pi 6. The way I like to do this is think about, well, we're 5/6 of the way to pi. So if we start right here, that's 0, and we go this way over to here, and that distance right there is pi, well, I'm 5/6 of the way to pi. Pi is 180 degrees. It's located at the 180 degree mark, right? So I got to put over here 180 degrees is where pi is located. So I want to take 5/6 of 180 because I'm not all the way to 180. I'm 5/6 of the way there. Let's just draw that in right now. Okay, so how do I get there? Well, 5/6 of 180. So 6 goes into 180. I'm going to do the division before I do the multiplication. 6 goes into 180 30 times. So now I've got 5 times 30, right? Because 6 went into 180 30 times, divided into there. And then we've got 150 for my final answer. There's number 3. All right, number 4. We want to figure out how many degrees there are right here in this arc, okay? So if this is 38% of the circle, 38% converted to a decimal is 0.38. You're going to take 0.38 times 360, okay? So yeah, you probably need, a calculator. So you jam over to here and you go 0.38 times 360 right into the Google Omnibar, and it says 136.8. I've seen a number of you guys doing that. I think that's pretty cool. I learned something new from you. I would not have thought to just type it into the Omnibar. So 136.8 degrees. Let's go to the next one, number 5. Hey, it says the two chords are equal to each other. So what conclusion can I make from that? What deductive reasoning conclusion can I make from the given information? All right, there it is. Now, if I subtract 5x from both sides, I'm down to 2x plus 3 equals 25, right? Did I do that correctly? Oh, yeah. Okay. So then I subtract 3 from both sides, and I'm down to 2x equals 22. Yep, did that arithmetic correctly. Divide by 2 on both sides, right? Divide by 2. 2's divide out to 1, so now I've got 1x. I just put an x there. I was going to put 1x. 1x is 11. Don't stop there because look, it says find the length of QR. So I take that 11 and I put it right there, right? So I'm going to go 7 times 11 plus 3. That's 20. No, what am I talking about? That's 77. 77 plus 3 is 80. Boom, 80 degrees, right? Thinking of a few different things this morning. Got to stay focused here. Oh man, I was so impressed with you guys on this one. So many people got this one right. How do you get this angle right here? We need to divide by 2 to get back to the inscribed angle. Divide by 2. So that angle right in there is 24 degrees because half of 48 is 24. We're dividing by 2. To go the other way, if I have the inscribed angle, I multiply by 2. So if I multiply that by 2, I get 146 degrees. All right. Let's see. We're on number 8. Nope, 7. We're on number 7. Oops. Number 7. How do we know that we have a tangent here? It's if it makes a right angle. If the line that's touching the circle in one spot makes a right angle with the radius, then we can confirm that this is actually a tangent line. Well, 8, 9, 10 does not make a Pythagorean triple. It doesn't work with the Pythagorean theorem because you get 64 plus 81. That's not going to equal 100. That's what I'm investigating right over here. That's my question. Does 64 and 81 make 100? Well, no, that's 145, I think. 145. 145 is obviously not 100. So this would be the best work probably to show that the whole Pythagorean theorem doesn't work. But sometimes you can avoid that work, right? Because 20, 21, 29 is on a poster on the wall. That means that this is a Pythagorean triple, which means that it would definitely work in the Pythagorean theorem. That's what Pythagorean triples do. They're whole numbers that work in the Pythagorean theorem. These are whole numbers, 8, 9, 10, right? Integers. But they did not work in the Pythagorean theorem. 20 squared plus 21 squared equals 29 squared. That's going to work for sure. You can test it out. Go ahead and do that. 20 squared plus 21 squared. It will equal 29 squared. I'll guarantee it. Otherwise, I need to take that poster down off the wall. Right over here, 12, 35, 37 is right there. I see it. It's another one of the poster 12, 35, 37, one of the poster Pythagorean triples. So that's a yes. So this one was a yes, and this one was a yes, and then the others are definitely a no. So this was a no, right? Just to clarify that. And then I think there's another one or two over here. Yeah, there's this one. This one's not going to work either. 5 squared plus 10 squared does not equal 15 squared. Does not equal 15 squared. 15 squared is 225. 225. This is 100. This is 25. See, I get 125 does not equal 225. Okay, so this is a definite no. This one right here, 10, 24, 25. People got confused here because you have 10 and 24. Those are both divisible by 2, and we're down to 5 and 12. But the third side would have to be 26, so that when you divide it by 2, you end up with 13. Well, it's not 26, it's 25. 25 is too small, That makes this an acute angle over here. Acute angle, less than 90 degrees. If the hypotenuse is too small, we got an acute angle. Hey, this one right over here. I think some of you did like a little guess and check. You saw the 15. You saw the poster on the wall over there. Where the heck? There it is right there. And you see 8, 15, 17. And you said, well, what if this was 8 right here? Well, then this radius would be 8. Would this side right over here be 17? It sure would. Now, the longer way of doing it, not that you're interested in a more difficult way, would be like this. You set up the Pythagorean theorem, which I saw a number of you guys do. That was fantastic. Oops, not that one squared, the outside squared. The problem was that you didn't do the arithmetic here correctly. I wish I wouldn't have put that there. It's got to be on the outside, the squared. So I get 81. You square that guy. I square the x right there, and I get x squared. But to get the middle term, you multiply these two together. That's 9x, okay? And then you got to double it. So you're going to get 18x. And we talked about why that works in class, when we had 9 plus x times 9 plus x, and you distribute the 9, you distribute the x, you're going to get 2 9x terms, not just one of them. Just look at that stuff. You get two 9x terms. That's why you're doubling that. You get x squared plus 15 squared. Right? Oh, should have done the 225 right there. So I get x squared plus 225 equals 81 plus 18x plus x squared. If we subtract x squared from both sides, the x squareds go to 0, which is super nice. If I subtract 81 from both sides, I'm down to 144 is equal to 18x, and 18 goes into 144 8 times. So that's another way to get the x value right there. Number 9. Well, 124 is not an inscribed angle. It's not a central angle. It's kind of at a random location. Here's the center right up here, right? If it was at the center and, we had 124 here, well, that would be 124 degrees. 124 is equal to half of 163 plus y. So you set up your equation, then maybe you multiply both sides by 2. Instead of distributing the half, I'm going to multiply both sides by 2. And what happens with the 1/2? The 2 times the 1/2 go to 1. So now I've got 163 plus y on the right side, and I've got 248 on the left side. I subtract 163 from both sides. And what do we end up with? 5, 8, 85. So y is 85 degrees. That's probably the fastest way to do that problem. Number 10. Well, x, look at where x is. X is over here. X in this arc and this arc added together in half is x, right? But I don't know that arc or that arc. So let's find something next to x, like y, okay? Well, y is half of 81 plus 53. Okay, 81 and 53 makes 134, I think. So I get 134 right there. Half of 134 is going to be 67. So 67 degrees is where the y is. But I don't want y. I want the x. So I got to go 180 minus 67. Because if this angle is 67, and that's a straight line right here, we got 180 degrees, for that straight angle. So I got to take 67 away. That's why I get 113 degrees right here. Okay, so 113 is the answer. If I didn't see any work, you may not have got full credit for that. You can put some work down, earn some points back. Thank you so much for following along on the test corrections. Have a wonderful break. I can't wait to see you in January.